Hello, it's Duncan. Today we're going to implement a fake version of an external API to allow us to test our software better. And along the way, we'll learn about http4k lenses. So last time we created this client for our pricing service, and maybe we should rename that to be value elf client. Now we had some tests which we disabled because we were actually talking to the real service. What's often really helpful in situations like this is to have our own version of an external service, a fake version, if you like, that we can run to stand in for the real thing. Maybe when we're working on the train, maybe when we want to simulate errors, that sort of thing. So let's get on and write ourselves a fake version of value elf. So here's a test to get us started, and we're going to connect our fake through our actual client. So here we've got this value elf client given a URI and some URI. So let's copy these from here into our test. But instead of connecting to the actual value elf, we want to connect to a server that we'll run ourselves. So it wants to be on localhost. And we'll pick a somewhat random port. So now our tests want to create a server on that port. They'll want to start the server. And now if we have an item like this one, we should be able to ask the client, what's the price for an item? And that should be the 609 that the actual value elf returned for that same item. So these were the tests against our real server, and we want to see that our fake returns the same. So we need to create a server, and that's going to be the port. And we'll pull this out of here into the top level so we're not relying on any of the test. Now we already have an abstraction for a server that we can start. We created one of those in HTTP here. Let's have a look at that. That seems to be one of those classes that is only really one public method. Maybe it should be a function. In fact, if we look at it, HTTP server already has a start on it. So this could in fact just be a function that returned the HTTP server. That's this thing. So we can get rid of that. Now let's see where that's called. The only place that's called is in main. So I think we could just rename this to be server for routes for. There we go. And then in here, this could return server. So this would be server for some sort of routes. Routes is an HTTP handler, which means that it needs to take a request and return a response that we're a punt for the moment. Well, this compiler won't work. I think I'm just going to comment this out and commit the change to server if it works. So let's just comment that out for now. Check that all of our tests work. In fact, it may be irrelevant that they do because the only place we were calling this was from main. But I think we'll commit that tiny change as it wasn't really part of this work, just a refactoring. So that is our main and our server. Just getting that change out of the way. Okay, back here. If we can start up a server, we really want to shut it down as well. And luckily, the http4k server is an auto-closable. So we should be able to say server start use, and then at the end of this block, it will be shut down. Now, obviously, this can't work because we're just returning a to-do here. But for now, we could return a response with the status of OK and a body with 609. And if we write that, will make our test pass because our client will parse this 609 in order to return this object here. Let's try that. Not quite, it seems. Let's have a look at what fails. We're getting a 503, which is connection refused, suggesting we haven't actually run the server properly. Let's have a look at that. And it turns out the issue is we're actually ignoring this port here. So let's go and have a look at server 4 again, and we're going to need to specify the port. Make a parameter out of that, call it port. That will change our main, but it'll also allow us in here to pass in the port. Run that. And that shows that we're now running up a server, actually on port 8888. And this would be a lot nicer if this lambda was on the outside. So let's go and just move this signature. So we'll move that up. And now that's a lot nicer. Okay, even for a fake server, I think we're faking too much here. What we really want is some roots in here. Let's remind ourselves what they look like. So we say roots and then bind method get to some sort of handler. Let's just take that and put it in here. So this is going to be roots like that. And we probably want to put this in the right path. So that will be /prices. Run that and see whether it still works. Good. Now, to be a good stand-in for testing, our fake server should actually parse the query string that we put in. So let's add in some code for that. So we want our ID, and that's going to come from our request query with an ID. And let's pull the client over so we can remind ourselves what we're getting. So our client was populating the request, and so our fake server should be pulling those things out of the request. We need an ID of item by calling the constructor. And that's nullable, so for now we'll just double bang it. This is also nullable, so we'll double bang that as well. We also want the quality, which is going to be a quality, and that wants to be a quality from the requests query of quality. Now then, that might be null, and that nastiness will get us running, at least for now. Now, having got the ID and the quality, we want to exchange them for a price. How should we do that? Well, we could hard code them in here, but it would be better if we specified them to our server. So our server could take a function, its own little version of pricing, which took an ID of an item and a quality and returned a price. I'll populate that in here by creating a map, price lookup. And now if we move this item up here, we can populate that with a pair. So the key will be item ID to item.quality, and the value will be our price of 609. And now in here, we're going to give this a function that takes an ID and a quality, and that can look it up in the map. Now that can return null, which is a reminder that in fact this pricing should be able to return a null, because we may not be able to look up an item. Well, that compiles, but isn't quite right, because in here, we know what to use that pricing function to look up the actual price and return that in the body. Now remember that our price toString is in pounds, and we're not parsing the pounds out here. So in fact, we want to get the value, which unfortunately isn't public. So let's just go to price and not only make this public, but also give it a better name than value, because this, if we remember, is in pence. So our price is in pounds. And we're still not compiling, and I suspect that's because this can be null. So here we can say if price equals null. Don't know what to do yet. Oh, and finally, I think we may need toString in here. One of those times when the Kotlin compiler really isn't clever enough to tell us what the issue was. Let's see whether that works. Well, after all that time since it last compiled, that's a relief. We've obviously got a lot of sort of debt around these bang bangs and so on, so let's address those now. This first test is for an item that does exist. So we created a server, we started it, and then we checked that we got out this 609 that we put in here. What about an item that doesn't exist? Let's duplicate this. So this is price that does exist, and this is no price. So here we could just have an empty map. In which case, we think we should get back null here. Let's just try that. And obviously we don't, and you'll remember then that because this to do here. So if the price is null, what do? Let's have a look at what our client does. Our client uses a not found to return null, so we need to return a not found here. Let's try that. Good. Now you're probably not noticing because of the power of editing, but every time we start up one of these servers, it takes a little bit of time. We're now up to over a second to run all our tests. So we'd rather not run the variations by actually running up a server. In http4k, because our client and our server both implement the same HTTP handler interface, we can actually just wire one to the other. So what we can do here is we can make this thing into its own function. And this will be value elf client. And note this takes a client of HTTP handler. We can just inline that and make this a single expression. If we make this public, then we can use this version over here. I'm going to duplicate this test and leave a version that does call the server, actually call server. But now in here, and now we're going to do the same thing with our server that we did with our client. We're going to stick just to the roots. So if we make this into a function, this is our value elf roots. Now, in our test, instead of creating a server and a client, we can create the roots here, which don't need a port, and we can connect those directly to our client. So we need to create a client, passing some sort of URI, which was this localhost one, and we can give it the roots directly. Now we don't have to start the server, and this will all happen in process now. Let's just check that actually does run. Splendid. So instead of running up a server with a thread pool and listening on a port and a client which actually makes HTTP requests, we can just wire the client direct to the handler. And in fact, not actually create an Apache client at all. This client just talks internally to this root. This will need a little bit of tidying up. We'll move our client here into this single test. And then let's make our other test look like this one. So we'll just create the roots here without the server. And then our assertion there. Let's run that. And now, at least for a little while, I think I'm just going to disable this test because this is a slow one. We can re-enable this at any time to check that our client and server do actually talk to each other over HTTP. But in the meantime, in all this logic, it's better to just cut out HTTP and talk in process. So our tests go from 1 second down to 800 milliseconds or so. There's now all this commonality in our test, this price lookup roots client. We can get rid of that duplication by moving item up. Now, if we make price lookup a mutable map, which is initially empty, then our test can populate it as they require. Let's see what that looks like. We take this version and move it up here. And now every time we can create the roots and the client. This top one is different. We'll just fold it away for now. And here, instead of creating the price lookup, we're going to populate the one that's been used by our roots. So here we can say price lookup with a key of this pair equals this price. And in order to make that work, this needs to be mutable map. And here. Now we don't need that. No price won't populate it at all. And our test is now really nice and simple. Let's just check that we're right. Good. Just see whether there's any duplication we can still take out of here. We've got our price lookup, so we could just populate it like this one does. Well, I think there's logical duplication in there, but not enough to worry about. Fold that away again and forget about it. Now, we had a lot of bodging going on down here around these bang bangs. And if we want to test invalid queries, then we can't do it through our client because our client sends valid queries. So if we want to test that we return bad requests or invalid query strings, we'll have to do that by hand. That's okay then. You can say we've got a request and we know it's a GET on our URI. Now we can use the routes rather than the client to process that request. And we can use some Hamcrest support in http4k to look at just the status. So we can say, assert that the response has status, and this should be bad request. We don't expect that to pass. And indeed, we get a null pointer exception almost certainly from this query ID here. So I'll just close this window, gives a bit of space. And first of all, let's pull this out into its own little variable. This is our ID string. And if that's null, we want to return bad request. The problem is this is a lambda and we can't return separately from a lambda. So we can't say, if that is null, return response bad request. What we can do though is convert this lambda into an anonymous function. And that allows us to return from here. So let's run that. And we're back to parsing. Let's fill in a few of the options here. We can inline this and make this, I think, base request. Now, if we have base request with a query of ID or some ID, we should still get bad request because we don't have a quality. We won't though, we'll get the null pointer exception from here. Let's fix that in the same sort of way as we did before. Run that. Okay. Now what are the case where we have a blank ID? That should also fail. That's in here. So where the constructor for ID fails, again, we want to return this response. Now we have a number of other ones. That is an empty quality, a quality that isn't a number, and a quality that isn't positive. So let's fill in some of those. Run all those. And we're getting a problem in here. So let's have a little fiddle. We can make this quality int by getting the request quality and doing toInt or null. And then we can put that in here. And then once again, this might fail, in which case we'll do this. Now that seems really quite a faff. We can cut quite a bit of it short with a let. So in here, we can take the result of this, say $.let, and put that into our ID. And then this is in fact our ID. And we don't need this one. And we can do the same thing with quality. And we'll just check that logic is right by running the tests. Before we go on, we can make things a little bit better here with a when. And then we can make this the subject of our when. Now, a little bit of importing makes this look not quite so bad, but it's still pretty ugly. If we now put our two pieces of code side by side, you see these are very much the same shape. They have a request. In this case, we're binding to a request. In this case, we're creating a request. And then we look at the query string for the ID on one side and we populate it at the other side, the same with the quality. And we've got this not found and we've got the body. You might think, is there some way of exploiting that commonality? And the answer in http4k is yes, we can use lenses. So let's see how we might do that. In order to do so, I think we're going to put both these pieces of code in the same place. So I'm just going to move these roots in here. And we'll just look at this file for now. Okay, so first let's have a look at a query lens. We'll create a lens for the ID at the top level. And they come from query. And for an ID, we want a non-empty string. And this is required. And we tell it the name of the query parameter we want. Let's have a look at the type of that. It's a BiDi lens, bidirectional lens, and it takes a request and returns a string. How can we use it? Well, we can use it in here to parse out our query. So this is returning a string. So in fact, we can say ID lens on our request. get a string. And because we said this is required, then the thing that's going to be returned is non-nullable. So the result can't be null. And so we don't need this question mark here. We can get rid of that. Let's just run our test and see what that gives us. We have a failing test. And the test is a lens failure that says here the query ID is required. And what's failed? Well, what's failed is the one where we didn't pass an ID. So lenses have to report that they're not working, and they do it by default by throwing an exception. So what we can do is we can catch that exception in here and use that to return our bad request. See whether that solves our problem. And it does. Now the nice thing then is we can also use the lens to populate the request. So down here, instead of saying .query, we can take our request and we can say with, and we can give it a list of lenses. So in this case, our ID lens, and that's going to be populated with item ID toString. And there's this little infix of that binds the two together. So if we do that, we can get rid of that. Lay this out a little bit better and run the tests. Okay, that's nice. Let's try the same thing on our quality. So we'll create ourselves a quality lens. Now quality is an int, so we'd like a lens that would extract an int for us. And so instead of non-empty string in here, we can use int. It is required, and the query parameter is quality. Now we can use that in here. So we can say quality lens on the request. That will extract an int for us that we can then pipe into the quality. And on the other side, we can add to the list of lenses. And here we can say quality lens of our items qualities value. Now this value isn't public, so let's go and have a look at that. What we'd like actually is an int, not a non-negative int maybe. So I think what we'll do is we'll add a property in here of value int. In order to get that, we take our value and get the value out of it. So it will save us making this public. Go back in here, and then this would just be item quality value int. This query goes, and let's try running that. Good. Now that's dealt with populating our request and parsing from our request. What about the response? Well, there's a body lens as well, so let's use that. And that's going to be body. We need a non-empty string. We need to tell it the content type. I guess that's text plain. And we can get a lens by calling toLens on that. What's the type of this? Well, it's a body lens returning a string. So we can use that in our routes to populate our response. So again, we can say with, and now we've got our price lens of our price events. And on the other side, we can use it to parse. So here we can take the response, use our price lens on our response, and it will get the body string for us. Check that passes. Good. Now you might say, why am I having to do it too long here? Can't I talk to my body lens and make it a lens of long, or even better, a lens of price? What we'd like is a body lens on price. How do we do that? Well, we can map on a lens. So in here we can say map, and that map takes two functions. One is next in, and that in our case is a function that will take a string and return a price. We'll check the type of that by just returning any old price in here. And now next out is a function that takes a price and returns a string. And we know that that is price pence toString. It's this one down here. Now this isn't compiling, and the reason is that this constructor here may return null. I think that's probably just the truth. So we need our lens to be a lens on a nullable price. That though means that this price parameter might be null, but this is the case where we'll actually be returning a 404, not using this to populate the body. So I think it will be an error for that to happen. So we'll put that here, and this is a program error. Okay, armed with that lens now, we can just take the price in here. And also in here, we can use the lens to extract from the response. So we take out that. See whether that compiles and works. It looks like we left our hard-coded value in. So let's go into here. And what do we need to do in here? We need to take our string to long or null and give that to a price. Run that. And we pass. Now we can play the same trick here with our ID and quality lens. So we can map those to parse out an ID and a quality. I won't bore you with that, so this will probably be speeded up. Phew. Looking back up here, we can see that all of our errors are now expressed by this lens failure, so that our logic is a lot simpler here. In fact, if we just pull our return out of the try, we can make this thing back into a lambda. These are complicated, to be honest with you. If I wasn't demonstrating lenses, I might not actually bother. And I think there's a place here where if we were to pass a negative int into here, that's not unexpected. So I think actually this is not an unexpected failure, it's just a failure. What actually happens is that http4k catches any errors thrown from these mappers and translates them into the lens failure that we're catching over here. Now, there are pros and cons to these lenses. They mean that our mapping code is in one place in here, and we can check that they are symmetric. The downside would be that if we make a change in here, we can change both our client and our fake server at the same time. And that might mean that we had tests that continue to pass, even though we'd actually changed the semantics of what happened and that they wouldn't work against the real server. In practice, I haven't seen that as a problem in real projects, but we should certainly run this disable test before we finish to check that we work against the real value of server still. So let's do that. And they still pass, which means that lens is working against a test environment. Depending on our relationship with ValueElf, I might have these tests run once a day or with every CI build, or just rely on developers to check they actually run if they've made any changes in this area. Well, that's been quite an intense refactoring. It's always hard to get these types right, but it's left up with code where the lenses can be used to both parse and populate requests and responses. As you've made it this far, I won't bore you with the check-in. But if you fancy suffering some more, then please subscribe to the channel to see how we use these fruits in production. And if you enjoyed the video, then I think you'll enjoy the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.